diagonals, if you will. That and that. And one is 24 and one is 6. What I do a lot of times is I do this thing. That would be my 24. That would be my 6. Not partial to this problem, but we would also know that this would be 3, 3, 12, and 12. Not crucial to that problem, but it's good to know that our diagonals are split in half on a rhombus. All right. Well, the area formula for a rhombus with diagonals is half diagonal times diagonal. So this one would be half diagonal 1 times diagonal 2. Well, half of 24 is going to be 12. 12 times 6 is 60 plus 12, which would be 72. There's no units, so unit squared or just leave it 72. I'm not too concerned about that. Yes, Labib.
When I was doing this, I forgot about that method, so I found the area of one triangle and multiply them by 4. Is that okay?
Yeah, that's the same formula, actually.
Oh,
You'd be surprised, and your formula actually looks a lot like that formula. Wasn't someone else in this class that asked that? Was it Krupa? No. Someone asked me about that too. Can you just have the triangle multiplied by 4? Yep.
Oh, yeah.
Yep. Same thing. You're going to get the exact same answer. You got 72, right?
Yeah.
You'll get the same answer every single time. That's called being smart. I didn't remember the formula, but I do know that there's 4 triangles. I know it's a base and a height because it's 90 degrees, so just multiply it by 4. All right, the other one. We have like 3 people that got it wrong, so let's pay attention. We have an isosceles triangle. Whenever I draw an isosceles triangle, I'm always going to draw it with kind of the congruent sides on top and this one on the bottom. And the reason why I'm going to do that is because if you drop a perpendicular on a isosceles or a equilateral triangle, it will divide the base in half. And that is because this side is the same as this side. That will cut this in half. Note, if that was anything different, if this was, say, 7, if this was 8, 7, 4, it would not cut it in half. It would, in fact, be more something like, 2.1 and 1.9 or something. All right? But because the sides are the same, it will split it in half, and so we'll have a 2 and a 2. Well, in order to come up with an area of something, you just have to have base times height divided by 2. Well, that means I just need to find this little guy right there. Well, I know 2 sides, so I can just do a squared plus b squared equals c squared. So, in other words, h squared plus 2 squared equals 8 squared. A squared is 64. 2 squared is 4. 64 minus 4 is 60, so you'd have h squared equals 60. Square root both sides, we'll have h equals square root of 60. And I would look on there, and there's no square root of 60. So that must mean 60 can be simplified. What goes into 60 and is a perfect square? What number goes into 60 and is a perfect square? Yes. 4 does. And how many times does it go into it? 15. So we can rewrite this as square root of 4 times square root of 15. In other words, 2 square root of 15. That is not the area, though. Area equals 1/2 the base times the height. So in this case, that would equal 4 square root of 15. Questions, comments, concerns? Still loving life? Right? Should. It's a pretty nice life. All right. Let us continue on with questions from the homework. Uh-oh, I'm not sure I have mine. Oh, there it is. Blue guy. All right, questions from the homework. EJ. Number 11. All right, number 11 says, basically we have a parallelogram, right? Yeah. Yeah, kind of. So let's draw that parallelogram. It looks something like this. Am I on the right one?
Oh, okay. I mean the second 11.
Oh, there's 2 11s. I hate when I do that. All right, that is FG is the altitude of the hypotenuse of triangle DEF.
Yeah.
Okay. All right, I'm just going to take a picture of it, and then we'll talk about it, why I did what I did. All right, so it says that FG is the altitude to the hypotenuse of triangle DEF. So if FG is an altitude to the hypotenuse, there's only one type of triangle that has a hypotenuse. That is a right triangle. A right triangle is the only one that has a hypotenuse. So that means triangle DEF is a right triangle. And it says FG is the altitude to the hypotenuse. That means F is already one that's labeled. So G must be the one that's on the hypotenuse. So that means that this is either D or E, or these could be flipped. All right, that would have been my initial drawing. This triangle here with this right here being my altitude. Well, it says to name 3 similar triangles and find their areas. So what I did is I drew EFD down here, with this being 10. Well, then I said, well, the one that would be similar to it with this F, because we can see a triangle right here, F, G, and D. If I drew it similarly, I would note that the 90-degree symbol has to go in the same place. So that means this G has to be in here. And D must be in the same place as all of these. So that means this had to be D. So that makes this one F. And we'll do the same thing with this E, F, G. I'm going to look at which one's 90 degrees. That is our G. I'll note that E is on top here. So E must be on top here. So that leaves me with just F. So our 3 similar triangles would be triangle DEF is similar to DFG, similar to triangle FEG. Well, then it says name 3 similar triangles and find their areas. So the first one, we have to use that heartbeat method, which was actually that extra credit that was on the test. The very first extra credit that was on the test was heartbeat method, means extremes. If you just would have did that, you would have got the points. We'll talk about the test in a second. But this would be the means extremes, or heartbeat. 8 over FG equals FG over 2, which means FG equals 4. Well, if FG equals 4, that's all we need to get the other triangles. This is my base. This is my height. So for the first triangle, it's going to be half of base, which would be 10, over my height, which would be 4. That's why I have half of 10 times 4 equals the area of this entire triangle. Then I went down and I said, well, FG equals 4, so FG equals 4 on this one. GD equaled 2, so I put 2 there. Well, the area for this one is going to be half of 2 times 4. Yeah. And then for our last one, EG, they gave us was 8. We found that GF is 4, so half of 4 times 8 equals the area of the third triangle. So it's a lot of just putting together pieces and using the means extremes heartbeat method. Right. Is that a little clearer? All right, other questions? Yeah, John. Yeah. Do I have 2 number 6s? I hope not. Number 6, there's multiple ways to do number 6. I'll show you one way, and then we'll look at the picture that I have. So it is a regular hexagon with perimeter of 60. A hexagon has 6 sides, so we'd have something that looks like this. Terrible job, but good enough for government work. All right, if its perimeter is 60 and all sides of a regular triangle are the same, that means this would be 10, 10, 10, 10, 10, 10. All right, the most important thing you need to do first is, since I have no values on the inside, we need to know the degrees of the angles inside of it. Now, you have to remember that formula that says, well, all of our interior angles added up would be n minus 2 times 180. Well, in this case, we have 6 minus 2, so we'd have 4 times 180 would equal 7. Would equal 720 degrees. So there's 720 degrees spread amongst 3 angles. So I would take 720 and divide it by 2. And you're going to find out that every one of these angles is 120 degrees. All right, so let's do 2 methods. One method people used was they divided it like this. They said, well, hey, I know how to find the area of a triangle, and I know how to find the area of a rectangle. So I divided it into a triangle, a rectangle, and a triangle. Well, to go further in that regards, what they most likely did is they divided these two up into smaller triangles and said, well, if this is 120 degrees and this is split in half, that would make this one 60. That would make this 30. And we have a hypotenuse of 10. So now we can use the 60, 30, 90 triangle to solve the rest of that triangle. When you solve this triangle, you get this full length and this full length. You'll be able to find the area of this triangle, and this rectangle. A slightly easier version of this would be what I did on the answer key. What I did on the answer key is rather than splitting up into a bunch of different shapes, I split it up into one kind of shape. I split it up into 6 equal triangles. Those are 6 congruent triangles where this is 120. So this is a 60, this is a 60, this is a 60, that's a 60, that's a 60, that's a 60, so on and so forth. So in fact, they're equilateral triangles. So once I knew everything was 60 degrees, I just pulled one of the triangles out and said, well, this is a 60, 30, 90. With 60, 30, 90, the one across from 30 is your S. Your hypotenuse would be S times 2, which would be 10. And this height would be S squared of 3, so it would be 5 squared of 3. So the area of one of those triangles would be half our base, which is 10, times our height, which is 5 squared of 3. And then I just multiply that by 6 triangles. I do think this is the easier method of the two, but both of them just work well. Everyone that did this method should have came out with 150 squared of 3 as well, which I saw most of you did, the people that got to it in class. All right, John, the major point is break it up into shapes that you know. Triangles and rectangles. Okay? All right, other questions? Yeah. The second 11? The first one, it should be 73.2. Because you do the sine of 50 degrees equals x over 8, which would mean x equals 8 times sine of 50, which means your height will be 6.1. And our area is going to be base times height, so it'd be 12 times 6.1, which equals 73.2. Jacob. 14 says the base of a triangle is 1 centimeter longer than the altitude. If the area of the triangle is 210 centimeters, how long is the altitude? So they give us the area. Area equals half of base times height. Well, it says the base is 1 centimeter longer than the altitude. So what I do is I'll let the altitude be x, and the base being x plus 1. So it's going to look something like this. Altitude is x. Base is x plus 1 because it's 1 unit longer. Area equals 1/2 my base times my height. And they said the area was 210. So now we have 210. I multiplied it both sides by 2 to get 420 equals x squared plus x. And then we end up having to factor it into x plus 21 times x minus 20. X plus 21 leads us to x equals negative 21. That doesn't work. This one leads to x equals 20. That one works. So our height, which equaled x, equals 20. It should actually be 20 centimeters would be a full correct answer on that one. Other questions? Okay, real quick on the test, just so you know, you can't earn more than 100% on a test with extra credit. Because earning more than 100% on a test means you know more than 100% of the material that was taught. And there's no way to show that on a test. So the extra credit really was just if you got mistakes, it canceled out mistakes. It was a kind of a catch. It just caught if you made mistakes, and I added up to 100. So that's why some of you might say, well, I actually had 102. You didn't. It's just 100%. Each extra credit was worth 1.5 points each, so it's a total of 3 possible extra credit points. So if you got plus 1.5, it means you had it correct. If you had anything else, that means you had something really good, but you didn't quite finish it. Exactly. All right, and everyone should have their test back. Test corrections, I don't think there's anyone here that has to do test corrections or can even do test corrections, but if you have below an 80, you can do test corrections. You have 1 week to see me and talk to me. Do it early. Don't wait till Friday after school and find out that I leave early because you didn't talk to me. It happens. You laugh, but all of a sudden it's just like I'm on my way out, and they're like, oh, I came to do corrections. It's like, no, you never told me. All right, guys, what I want you to do, you'll note that there is a kind of a lesson. There's